This lesson is for day 2 of system model problems. Today we're going to be doing the tortoise and hare rematch problem. This is a slightly more difficult problem than yesterday, and you're going to see actually that we give you the equations for the system rather than asking you to come up with them. And the harder part, the reason why this is harder is because you have to actually then interpret the equation rather than come up with it yourself. And it's actually sometimes harder to do. So tomorrow in class you're going to get practice at doing 3 of these questions, and then you'll probably see this on your quiz. So let's read the problem. It says, coming off an embarrassing loss to the tortoise, the hare wanted a rematch. The tortoise, being a wise old animal, wants a head start, and the hare agrees. Assume that both animals start at the same point. So we're going to let x equal the number of minutes since the tortoise has started, since he's getting the head start. Now t of x is the distance or number of feet the tortoise has gone after x minutes, and h of x is the number of feet the hare has gone in the same amount of minutes. Alright, now we're going to answer the problems using these 2 equations here, for the tortoise and for the hare. And after we answer some of these problems, then we're going to look back and try to interpret this. For right now, let's just use the 2 equations to answer some of these questions. Alright, in part A here, it says find t of 35 and h of 35. So go ahead and do that. Remember, you're plugging in 35 as your input for x. So after 35 minutes, the tortoise has traveled 1,750 feet. So after 35 minutes, the tortoise has traveled 1,750 feet, while the hare has traveled 800. In question B, it asks when will the hare catch up with the tortoise? So this is going to cause you to have to interpret here. If they're going to catch up to each other, that means that their distance is going to be equal to each other. And the distance, t of x, is representing the distance of the tortoise, and h of x represents the distance of the hare. So we're going to set those 2 things equal to each other. So we're going to set t of x equal to h of x. This is going to be the point where they cross one another. So if we solve 50x equal to 160 times x minus 30, we end up with x equaling 400, actually it's 4,800 divided by 110, but I just canceled the zeros to get 480 over 11. So this is the number of minutes, okay? This is the number of minutes, and this does not actually answer the second question, which says how far from the starting point. So first I want to work on the number of minutes here. If I divide 480 divided by 11, I get approximately 43.64 minutes. Now I want to change that, this 0.64, into seconds. So I multiply 0.64 times 60 to end up with 38 seconds. So after 43 minutes and 38 seconds, the hare catches up to the tortoise. Now, the second question says how far from the starting point. So what I'm going to do now, because this function, h of x or t of x, gives me the distance, right, how far they've gone, I'm going to plug in this number, this 480 over 11, because that was the time, that's x. And I'm going to plug that in for x into either function, t of x or h of x, because at the same time they'll be the same, distance away from the starting point. So let's plug it in. Now it doesn't matter which function that you plug it into, because remember that the distance should be equal at the same time, because that's what we're trying to find. We're finding the point where they end up crossing paths. So I plugged it into the tortoise one just because it was a little bit easier. I just had to multiply that number by 50, and I get 2,181.8 feet. So now when we answer this second part here, when it says before starting the 2 animals agreed that the race would be 2,000 feet, right away we can tell who won because the hare doesn't catch up to the tortoise until 2,181 feet. So the tortoise does win. Okay, now let's try to figure out 2 different things here. by how many feet. We want to figure that out, but I also want to know how much time he beat him by. So I'm going to add this question here. Okay, so I want to know how many feet and how much time he actually beat him by. So in order to do this, I can set up and find out how long it takes the tortoise to travel 2,000 feet. Okay, I'm going to figure out the time if his distance is supposed to be 2,000 feet, and I'm going to do that as well for the hare. I want to know at what point when he reaches 2,000 feet, like how long has passed. So I solve the equation 50t equal to 2,000, and I get, oops, sorry, it's supposed to be an x here. This x was number of minutes, so 400. 40, geez, sorry, 2,000 divided by 50 is 40. So this is saying after 40 minutes, he reaches the finish line, the 2,000 feet. Now the hare, if we solve his equation, this is 160 times x minus 30 equal to 2,000. This time I get, and I just did the calculation ahead of time, but I get 42.5 minutes. So this is another reason why you can tell that the hare lost the race, because traveling the same distance, it takes him 42.5 minutes to get there, while as the hare, it would be 40 minutes after the start of the race. So the hare beats him, or sorry, the tortoise beats the hare by 2.5 minutes. Okay, now we figured out how many minutes the tortoise beats the hare by, right? We figured out the time. Now I want to know by how many feet he actually wins by. So if you were picturing, you know, a tortoise, God, I can't draw, but a tortoise and then this little like bunny here, the hare behind him, he crosses the finish line first. I want to know what the distance is between them at the point where, you know, the tortoise crosses. So in this case, I want to know at 40 minutes, this is how long the tortoise takes to win, right? He crosses it at 40 minutes, he crosses the finish line. Well, I want to know where the hare is at 40 minutes. Okay, so what I'm going to do is find h of 40. This is going to tell me where the hare is precisely at the 40th minute when the tortoise wins. So h of 40 is going to be found by taking 160 times 40 minus 30, and that gives me 160 times 10, and you could do that in your head. You get 1,600. Now that means that he's 1,600 feet away from the starting point, which means that the tortoise, who's gone 2,000 feet at the same moment when the hare has gone 1,600, means that that tortoise has beat him by 400 feet. So he beat the hare by 2.5 minutes and 400 feet. Okay, that would answer that question. All right, now for part D, it says how much of a head start did the tortoise get in minutes? So I want to take a look at our original functions, t of x, which is 50x, and h of x, the hare's, did I just call him a hortus? The hare's speed, which was 100, or his function, 160 times x minus 30. Okay, so I need to take a look at these two equations here and break it down for you guys so that it makes sense why I'm getting the answer that I'm going to get here. Now, remember, we're just doing basic distance equals rate times time problem. You know, you're running a race, you go a certain distance, it's computed by taking your rate times the amount of time that you're running that race for. Now, the distance is t of x. So we have distance equals, and then here, this expression must be rate times time. Well, x, we know, is the number of minutes, so that is the time. So that means this 50 here represents the rate. So the tortoise is going 50 feet per minute. So that's the tortoise's speed. So I actually just answered part E here. Now, in the second question, in the hare's function here, it's the same idea. The distance is equal to rate times time. This expression here gives me a time. So real quick, I want to obviously do the rates a little bit easier here. The hare is going 160 feet per minute. Okay, that one's a little bit more obvious. It's right here. And then the time here actually tells me what the head start that the tortoise got. Because this is like the headwind or the tailwind problems when we're talking about the speed of the plane. So remember, when you have a tailwind, it aids the plane in its rate. So you take the rate of the plane and you're going to add the tailwind speed because it helps, it pushes the plane a little bit faster. In a headwind, you take the plane's original speed and you subtract that amount. It's very, very similar here when we're looking at the time. The expression here, it's saying at a certain time, he's going to have to wait 30 minutes. So the tortoise here got a 30-minute head start because that's how much that the hare here was delayed. He was delayed by that 30 minutes here. Okay, so I kind of wrote all over the place here. My apologies, but that's essentially what this part here is saying. The time here is delayed by 30 minutes because you're taking whatever the tortoise started at, and the hare has to wait 30 more minutes before he can even start the race. All right, we answered part E, and all that's left now is part F. So I think these numbers are kind of tricky to try to place on this grid here. But yeah, let's try to blow this up as much as I can to fit it. Okay, so when we're trying to adjust our scale here, the first thing you want to do is make sure you're listing all of your coordinates that you've found, in the beginning parts of this. Well, you know that you've got t of 35. You also have h of 35, which is going to give you two coordinates. I'm writing these in different colors because our hare function does not share the same points as our tortoise function, right? These are two separate lines, so I want to make sure I keep those separate from each other. So at 35 minutes, that was 1,750 feet for the tortoise, and at 35 minutes for the hare, he is at 800 feet. So that's how you're going to list your coordinates here. When you do that, it's going to be kind of difficult to pick a scale. I want to pick the same scale for everybody here so that tomorrow you guys can ask me questions on it, and then I can see that you have all the same scale. You don't have, obviously on a quiz or a test, you don't all have to have the same scale, but I just want to make sure on the notes here that you do. So I want to go up to 40 minutes and let each of these here boxes represent 2 minutes. So that's just going to be 10, 20, 30, and 40 minutes. So this is your x-axis here is the number of minutes, and our y-axis is the distance. And let's see, it went up to 2,000 feet, so the race was 2,000 feet. I'm going to put 2,000 here. Even though we do have a couple of points that are going to be off of this, like we know that the hare took 42.5 minutes to reach that 2,000 distance, and so on. So I want you guys to go back, look at all the coordinates that you have, and plot some points. Now, you're going to find actually that one of these is going to be really funky when you graph it. They're not going to both be coming from a y-intercept over here. When you graph this tortoise function, y equals 50t, or x, why do I keep saying t, sorry, y equals 50x, this is going to have, the coordinate 0, 0 here, but the hare's function, let's call it h of x, since I want to keep the notation consistent. So h of x does not go through the, doesn't have a y-intercept here that you can see in this quadrant. So this function actually is going to start all the way out here. And it's going to look weird to you because you're going to be used to, only graphing stuff with a y-intercept in the positive, but this has an x-intercept because, again, his time was delayed, and that's why we're starting here at 30 minutes. So I just kind of gave you a big hint on this, but I want you to graph this and come to class tomorrow with this finished. I might even make that your video quiz, okay? All right, I hope you had a fabulous time doing this problem. I know it's so exciting, but I will see you tomorrow.